Hi, today we'll look at a stoichiometry problem involving mixtures. And the problem which we're going to look at is this one here. Upon heating a mixture of aluminum chloride and calcium chloride, the mixture is reduced to pure metal containing no chlorine. The only gas emitted in the process is Cl2. So we see that aluminum chloride is losing its chlorine to become aluminum plus Cl2. We'll want a balanced chemical reaction, so that will be as written. And we have calcium chloride, which is turning into calcium metal plus chlorine, and that's balanced as written. Now, I've written this as two separate reactions, and that's important. The amount of aluminum chloride that's being turned into aluminum and chlorine has no bearing on the amount of calcium chloride which is being turned into calcium plus chlorine. I could have a lot of aluminum chloride in my mixture and it will react, and I could have a lot of calcium chloride and it will be turning to part. And whatever they do, they're going to do it independently of each other. And if they're independent of each other, the reactions are separate. And the reaction is going to 100% completion, 100% yield, because we see that all the chlorine has left. And so looking at those two balanced reactions, we see that the number of moles of AlCl3 we start with is equal to, was two of those going to two Als, is equal to the number of moles of Al, and the number of moles of CaCl2 that we start with is equal to the number of moles of Ca that we end with. And now we're going to use some algebra to express the facts that we see, the numbers that we see in the problem. We see that we have the grams of the initial mixture. The grams of the initial mixture is 120.34. And it's based on the amount of AlCl3, and we have its molecular mass. The molecular mass of AlCl3 is 133.34. Molecular mass times the number of moles is the grams of AlCl3. So 133.34 times the number of moles of AlCl3 is the grams of AlCl3. And we've also been given the molecular mass of the CaCl2, 110.98 times the number of moles of CaCl2, and that's equal to 120.34. And then afterwards, the mixture is only weighs 33.456 grams. A lot of chlorine has left the system, and it's all aluminum. Now, the number of moles of aluminum, we have it written right here, is the same as the number of moles of AlCl3. And what we want in equations is to have as few variables as possible. So instead of writing number of moles of aluminum, since I've already used number of moles of AlCl3, I'm going to write number of moles of AlCl3. So, number of moles of AlCl3 is the same as the number of moles of Al. If I look up the atomic mass of Al, it's 26.982. And so, number of moles of Al times 26.982 is the number of grams of Al, and I can write the number of moles of ALs as NaCl3. And then we can look up the atomic mass of calcium, which is 40.078, and we're looking this up in the periodic table, times the number of moles of Ca, and the number of moles of Ca is also the number of moles of CaCl2. And now we have two equations and two unknowns, number of moles of AlCl3 and number of moles of CaCl2. And the easiest way for us to now treat these two problems is we have really very big numbers and we want to move them around as little as possible. And the way that we're going to do is we want to get rid of the number of moles of CaCl2. So I'm going to divide the second equation by 40.078. And then I'm going to multiply by this number here, 110.98. And then I'm going to subtract the bottom equation from the top equation. So let's just see why that's good. 40.078 here divided by the 40.078 here, they cancel. We're left with a 110.98, and when I subtract that from the plus 110.98, we remove all the moles of NaCl2. So that's the math we want to do. And now we're introducing a combination of mental math and the calculator. And what you want to do is really write as little as possible. And we're going to do that right here. We're going to take 26.98 and I'm going to divide it by 40.078. And then I'm going to take those two things and multiply by 110.98. And then I will subtract that number from 133.34. So I'm going to say again what I'm going to do, but I'm actually just going to plug the numbers into the calculator. 26.982 divided by 40.078 times by 110.98, and then subtract that from 133.34. And if you do that, you get 21.1708 NaCl3. And now we know that the second term cancels, and we're left with the final term. That's going to be 33.456. Remember, we're going to do this all in the calculator. It's kind of a weird combination of mental math and calculators. 33.456 divided by 40.078 times by 110.98, subtract it from 120.34. And if I do that, I get 10.0022. So we can now solve for the number of moles of AlCl3, and we get 0.472 moles. That's the answer to our problem. And we'll practice doing these mixture problems tomorrow in class.